Hi everybody, in this video we're going to go over the review sheet for test number 2. So in question number 1, we need to explain why the lines are parallel, why this construction makes the lines parallel. So I see that this correct construction is created by copying angle 2 to where angle 1 is. So I'm going to pick the first choice, that angle 1 is equal to angle 2, they're congruent angles. And this construction works because angle 1 and angle 2 are both top right in the same position where the lines meet the transversal. So we call them corresponding angles. And if corresponding angles are congruent, then lines are parallel. So we can conclude that the lines are parallel from the congruent corresponding angles. Okay, in number 2, our goal is to find this angle. We also have information about this angle. I'm just going to highlight for a second my lines, cup on my transversal, and these lines are parallel because it says in the question that we have parallel roads. Notice the backward Z shape. That tells us that we have alternate interior angles inside the lines on different sides of the transversal. We have alternate interior angles. And when we have parallel lines caught by a transversal, alternate interior angles are congruent. So I'm going to write that here, alternate interior angles congruent when parallel lines are cut by a transversal. Okay, so 2x plus 33 is equal to 5x minus 15. 33 is equal to subtracting 2x on both sides, 3x minus 15. 48 is equal to 3x after we add 15 on both sides. And our last step is just to divide by 3. And I have x is equal to 16. Now I'm just going to plug in to find what the measurement of the angle is that we're looking for. The angle formed by the intersection of Walnut Street and Elm Street. So Walnut Street is here and Elm Street is here. So let me first find this angle because now I have my x value. So 16 times 2 plus 33 is 65 degrees. And then we're actually looking for this angle here, which is supplementary to the angle that we just found. So if we do 180 minus 65, we get 115 degrees. And that's the angle that we're looking for, formed by the intersection of Walnut Street and Elm Street. Okay, given AC is congruent to ED, how can we prove that AD is congruent to EC? Notice how we're given information about the small segments AC and DE, and we want to prove something about the longer segments AD and CE. In order to do that, when we have information that's too small and we need to make it bigger, that's addition postulate. So I'm already going to knock out everything with subtraction because we're not making things smaller, we're actually making things bigger here. Let's take a look at what we're adding. If we start with AC and we add on CD, we get the whole AD. So AC plus CD gives us AD. If we go from the other direction and we start with ED, and to ED, we add on DC. We get the whole line segment EC. So we're starting with two congruent segments, AC and ED, that was given to us. Are we adding on two congruent segments? You might be saying yes, because CD and DC are the same segment. Here's CD, here's DC. They're the same segment. So we can state that CD is congruent to DC, or that CD is congruent to itself, CD is congruent to CD by reflexive postulate, which says that anything is congruent to itself. So the answer choice here is number 1. Okay. So I'm not going to trust the diagram by the way that it looks, but I see that I have a bunch of supplementary relationships over here. Any two angles next to each other are supplementary. So I can fill in some angle measurements. I also do have vertical angles, a lot of them, and vertical angles are always congruent to each other. So I can fill in some measurements. I'm going to fill in here, this is 120, so this needs to be 60 to make 180. And I could say this is 60 because it's a vertical angle. This is 120 because it's a vertical angle to the original 120. And I can keep moving around and filling in measurements. But this is all I need. I'm going to just highlight these two lines and the transversal that intersects them. Notice that the 60 degrees is bottom left and the 60 degrees is bottom left. They're in the same position where the lines meet the transversal. So they are corresponding angles. And since they are congruent, that actually shows the lines forming them are parallel. And the lines forming them are line D and line E. I'm going to write that here. Since corresponding angles are congruent, lines D and E are parallel. You could also find congruent alternate interior angles, or you could find supplementary same-side interior angles to show that lines are parallel. Any one of those would work to show lines are parallel. Here, the corresponding angles was the easiest one to find. I only had to find one number to find that. Okay, when I label the segments, I want to make them look different from each other. You are going to lose points if you mark all of these segments the same way and it appears that they're all congruent to each other. So let's go one by one. AB congruent to AD, BE congruent to ED, EC congruent to DC, BCA congruent to DCA, angle AED congruent to angle BEA, CDE congruent to angle EBC. Okay, so in the first one, the error is in the formula itself. They forgot the radical, and that's something that a lot of people do, and it really does change the answer. Remember, distance formula is radical x2 minus x1 squared plus y2 minus y1 squared. In this one, 6 is an x-coordinate, 2 is a y-coordinate, but they put them in the same parenthesis. The first parenthesis should just be the x-coordinates. So this could be 6 minus 1. The second parenthesis should just be y-coordinates. So they mixed and matched x and y coordinates. To correct the error, I'll use 1 first, x2 minus x1. Y2 minus y1. 1 minus 6 is -5 squared is 25 plus -4 minus 2. -6 squared is 36. 36 plus 25 is 61. And I am going to leave my answer as a radical. I'm not going to get approximation. It doesn't say to round. So the first person was almost right. They just forgot the radical. Okay. Quadrilateral ABCD. A is -1, 1, 2, 3, 4, 5, 6. And once again, you don't have to use the grid. B is 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. There we go. So we can see that this is a four-sided shape, and we can see that the sides are AB, BC, CD, and AD. In part A, we're showing that it's not equilateral, that all the sides are not equal. So we want to find the lengths of each of the sides. So that's going to be distance formula. And of course, I'm going to go into here because I'm not going to have enough space, but we're not going to need all the space over here in question number. So I'm going to go with AB first. 3 minus -1 squared plus 8 minus 6 squared is equal to 4 squared is 16. 8 minus 6 is 2 squared is 4. Radical 20. BC, 6 minus 3 squared plus -1 minus 8. 3 squared is 9 plus -9 squared is 81. And that gives us radical 90. CD, and I'm going to have to do AD somewhere else. CD is 1 minus 6 squared plus 0 minus -1 squared. 1 minus 6 is -5 squared is 25 plus 1 equals radical 26. And finally, one more to go, AD. I'm going to do AD over here. AD is 1 minus -1 plus 0 minus 6. 1 minus negative 1 is 2. That's 4 plus 36. That's radical 40. Okay, so my conclusion is going to be, since none of the sides are equal, ABCD is not equilateral. I just want to put a reason why what I was trying to say is true. So we were trying to say that ABCD is not equilateral. So I showed that it's not equilateral because I showed that it doesn't have equal sides. All the sides are not equal. In fact, none of the sides are equal. Same kind of question is going to be on the test, except it's going to be a triangle with only 3 sides and not a quadrilateral with 4 sides. Okay, so midpoint of AB, going to use midpoint formula. So midpoint formula for AB, -1 plus 3 over 2, 6 plus 8 over 2. That is 2 over 2, which is 1, 14 over 2, which is 7. Midpoint of BC. So for BC, that is going to be 3 plus 6 over 2, 8 plus -1 over 2. So that is 9 over 2, comma 7 over 2. CD. So for CD, that is going to be 6 plus 1 over 2, -1 plus 0 over 2. So that is 7 over 2, -1 over 2. And finally, one more midpoint to find. That is the midpoint of AD. So that is going to be -1 plus 6 over 2. Oh, sorry, messed that up. -1 plus 1 over 2. And then the average of the y coordinates, 6 plus 0 over 2. -1 plus 1 is 0. 0 over 2 is just 0. 6 over 2 is 3. Here we have all our midpoints. Once again, there's going to be the exact same question on the test. It's going to have a triangle, and it is going to have you find the length and the midpoints of the sides. Okay. Lines AB and CD intersect at E. AB, CD. If measure of angle AEC is 7x plus 16, and measure of angle BED is 3x plus 48, what is the measure of angle CEB? So the two angles that we're given information about are vertical angles, so they are congruent to each other. So I can set up the equation 7x plus 16 is equal to 3x plus 48. Solving really quickly, 4x is equal to, let me add 48 and let me subtract 16 from 48. So we subtracted 3x from 7x. Let me subtract 16 from 48. And I got 32. And dividing both sides by 4, I got x is equal to 8. Let me plug in to one of the angles. They're both the same, so I'll just plug into the top one. So 7 times 3, or 7 times 8, sorry, our x value is 8. 7 times 8 is 56. Plus 16 is 72. oops, 72 degrees. So this angle and the one next to it are supplementary. So if I do 180 minus 72, that gives me 108 degrees. And that's the missing measurement over here. That's the measurement of angle CEB, 108 degrees. Okay, find the value of x. CD is parallel to EF. AB is a transversal. Angle DGH is 2x. And measure of angle FHB is 5x minus 51. Find the measure in degrees of angle BHE. So we have parallel lines cut by a transversal. And I notice that this angle is bottom left, and this angle is also bottom left. So they're in the same position. That means they're corresponding angles, and corresponding angles are congruent when parallel lines are cut by a transversal. So we have 2x is equal to 5x minus 51. Subtract 2x. Actually, I'll add 51 and subtract 2x. So 51 is equal to 3x. Let me take a second and divide both sides by 3. And I have x is equal to 17. Now I need to find the measure of angle BHE. So first I'm going to plug in here. So 5 times 17 is 85 minus 51 is 34. So this is 34 degrees. These two angles next to each other are supplementary. 180 minus 34 is 146 degrees. So this angle over here would be 146 degrees. In the next question, we're going to construct a parallel line to line AB that passes through point C. So what I'm going to do is I'm just going to draw a transversal with my straight edge right through point C. And if you make it slanted, it's a lot easier to work with. On the computer, mine is probably going to be a little bit inaccurate because as you see, my straight edge here didn't pass right through the point. I'm trying to move it slightly, but I'm just leaving it as is. Okay, so what we're going to do is we're going to take this angle and we're going to copy it up here. So I'm going to put my compass at the vertex of the angle that we're copying. And I'm just going to open up my compass a little bit. The exact length doesn't matter, or if you're using the flat one, the hole doesn't matter. Make an arc, go up to point C where I'm copying the angle to, and I'm going to make the same arc. Okay, now I actually have to measure the angle that I'm copying. So notice how there's two spots where the angle hits the right. So I'm going to take my compass and I'm going to measure that length. I'm going to put my compass on one endpoint, and I'm going to open up to where the other endpoint is, and I'll just make an arc to show that I measured. And pick up my compass without changing the length that I just measured. I'm going to go up to where my first arc hit the line, and I'm going to make the same exact arc. Notice how there's an intersection point? That's where my parallel line is going to pass through. So, okay. There we go. And here we have a line that's parallel to the original. So the reason that this construction works is because we copied this angle from here to here. So we made congruent corresponding angles, top right, top right. We made congruent corresponding angles. And if corresponding angles are congruent, that makes the lines parallel to each other. Okay, this one we're going to fill in the missing pieces of the proof. So angle 1 is congruent to angle 3. CE bisects angle DCB. I know that if we have an angle bisector, it splits the angle into 2 equal parts. So I'm going to mark that in my diagram. Since I'm using different colors, this looks really horrible on the computer. I'm just going to use the same marking because I'm using different colors. Okay, and we need to show that lines CE and AB are parallel. So what we're given to work with is that angle 1 is congruent to angle 3, and that line CE bisects angle DCB. Yes, you have to write all of your givens. Your given information is your starting point for writing any proof. We already concluded together that angle 4 and angle 3 were congruent. And we said that because we have an angle bisector. And we know that an angle bisector splits an angle in half or into 2 congruent parts. So the reason for the next one is transitive property. So let's think about what the statement should be. We already have angle 1 is congruent to angle 3. That's from the givens. Now we concluded angle 3 is congruent to angle 4. That's from the angle bisector. So notice how angle 1 and angle 4 are both congruent to the same angle 3. If they're congruent to the same angle 3, then they have no choice but to be congruent to each other by the transitive property. Once again, the transitive property says if two things are congruent to the same third thing, then they have to be congruent to each other. Now let's take a look at these angles 1 and 4 that we just concluded about. So here's 1, here's 4. I just marked them in purple. We want to show that this line is parallel to this line. And these two lines are intersected by a transversal. Where this transversal meets the bottom line, we have top right, it's angle 1. And where the transversal meets the top line, we have top right as well. That's angle 4. So notice how angle 1 and angle 4 are corresponding angles, and we showed that they're congruent. If we have congruent corresponding angles, that proves that the lines forming them are parallel. So I'm going to write that down. If corresponding angles are congruent, then lines cut by a transversal are parallel. And that's all there is to it.